Okay, the topic in lesson 35 is called factoring the greatest common factor. Now, as you'll remember, we just recently got done talking about finding the greatest common factor. There's a difference between finding the greatest common factor and factoring the greatest common factor. Let's review what we mean if we're asked to find the greatest common factor. So in this example that I have, what we're going to do first is we're going to do a factor tree for, or in other words, product of primes for 4, which I could break down to 2 and 2, which is 2 squared. And then I'll break down 6 to 2 times 3. And so here I have just for the numbers themselves, I have 2 squared, I have the product of primes, and here I have 2 times 3. Now, the greatest common factor then is what's common in both those. So in other words, do you have a 2 in both those? And the answer is yes. And remember we said you'll take the lower exponent. So do I take 2 to the first? Remember that's a 1 there. Or 2 squared, and you'll take the 2. Now is there a 3 in both those that I have a rectangle around? And the answer is no. So the greatest common factor for just the numbers is 2. Now how about the letters? Now I have a to the first and a cubed. Well, I'll take the lower exponent, so a to the first. And then do you have b's in both? The answer is yes. Take the lower exponent because this is b to the first, this is b squared. Now do you have a c in both? The answer is no. So your greatest common factor is 2ab. So here we found the greatest common factor. Now what we're going to do here in the next two examples that I have is factor the greatest common factor. So in other words, what we just did, we found the greatest common factor. Now we're going to look at factoring the greatest common factor. All right, in example 1, we're going to factor the greatest common factor. So first of all, the number one thing that we do first is we're going to find the greatest common factor first. So let's do that. Let's take our 15 and let's break that down, and that would be 3 times 5. And let's take our 35, which would be 5 times 7. So I'll put a rectangle around here. So here I have 3 times 5. And here I have 5 times 7. Now what's common between the two of them? You have a 5 in both. Now let's do the letters. I have an a squared and I have an a to the first, right? So take the lower exponent, the a to the first. Now do you have z's in both of them? Answer is yes. And take the lower exponent, which is z to the fifth. That's it, right? Now that's my greatest common factor. Now to factor the greatest common factor, I put a big set of parentheses. All right? Now this is where it gets a little bit more complicated. Now I'm going to underline this first term in pink, and I'm going to underline the second term in blue. All right, now in the pink, so in other words, I'm going to underline this part with pink, and I'm going to underline this part with blue. And then I'm going to put a minus sign in between them, because notice here is a minus. Now watch how I do this. Factoring the greatest common factor actually is the distributive property in reverse. So what I want to do here is I want to ask myself, what can I multiply 5 by? What can I multiply 5 by to get this? So 5 times what gives me 15? Well, 3. And let's see, I have an a to the first here. I took an a out. There were 2 of them here, weren't there? So that means I have an a left. And I'll kind of re-explain this as we go along. Now I have a z to the 5th here. I had z to the 8th. Let's see, I took 5 z's out. That means I have 3 of them left. All right, now I've got half the problem done. Now what I've done here, let's check this. I should be able to distribute 5az to the 5th times 3az cubed and get this. Let's see, 5 times 3 is 15, right? What's a to the first times a to the first? And I get a squared. What's z to the 5th times z cubed? And I get z to the 8th. So I've done this correctly. So again, it's kind of like the distributive property in reverse. Now let's do the blue part. 5 times what would give me 35? 7. Let's look at the A's. I took one of them out. There was only one of them, so I don't have any A's left here. I had 5 Z's. That's all I started with. So this is all I have left, is just in the blue part I have a -7. Now let's check this. I should be able to take this times 7 and get this. Let's see, 5 times 7 is 35. So let's see, 5, a to the first, z to the fifth times 7 gives me 35a, z to the fifth. So my answer is this right here. It's a little messy, but I factored the greatest common factor. Let's do one more example. Let's find the greatest common factor first. All right, so 2, I cannot break that down anymore. Same thing here. I can't break that down anymore. Same thing here. So what's my greatest common factor? All right, I've got a 2 in all of them, right? Now how about A's? I have an a squared, a cubed, a to the another a cubed, so I take the lower exponent. B's, I have a b squared, b to the 6, take the lower exponent. And that's it. Now I'm going to put a big set of parentheses. Now how many terms do I have? 1 plus another one plus, because of the plus sign, and then another term. All right? Now, I want to ask myself, what can I take this by to get this? Let's see, I already have the 2, right? So I have 2 A's, and notice there's 2 A's up here. I have 2 B's, and there's 2 B's up here. So really, all I have left there is a 1. Because would you agree, if I distributed this and checked it, what's 2a squared b squared times 1? Well, it's 2a squared b squared, right? Anything times 1 is itself. Now let's do the next one. I've got the 2, right? Let's see, I have 2 A's. I need one more. I have 2 B's. All I need is 2 B's, so that's it. So supposedly then, I should be able to take this times a and get this. Let's see, what's 2a squared b squared times a, or a to the first? Well, I get 2a cubed b squared. Now let's do the last part. I've got a 2. That's all I need is a 2. I've got 2 A's. I need one more. I've got 2 B's. How many more B's do I need? I need 6 of them, so I would need 4 more. So b to the 4th. Now, if you took, and let me just show you this, if you took 2a squared b squared times a to the first, b to the 4th, what do you get? Well, you got a 2. A squared times a to the first is a cubed. B squared times b to the 4th is b to the 6th. And notice, that's what I have right there. So, this is factoring the greatest common factor.